Hello, biologists, and welcome to our second video on X-linked inheritance. This one has an important twist, so I'm going to break it down step by step and show you what exactly we mean when we say ambiguous case. So keep that in the back of your mind. But the first thing we're going to do in all of these questions, always, is read them very carefully to see what inheritance pattern we're using, set our alleles, like see what traits we're dealing with, and see what the parents are described as. So we just have to start by reading this very carefully. So it says here, in cats, fur color and eye color are sex-linked traits. So that's a lot of information already in that first sentence. We see that we're dealing with two traits, and we see that they're sex-linked traits. So that's our pattern of inheritance here, sex-linked. We're going to keep that in mind. It's going to circle that. So then it says that brown fur is dominant over orange fur, and yellow eyes are dominant over green eyes. Okay, so that's all very important. Right now, right off the bat, we can set our alleles, but let's just keep reading through this one time. An orange-furred, green-eyed male cat is crossed with a brown-furred, yellow-eyed female cat that is heterozygous for both traits. What are the genotypic and phenotypic ratios of this cross? So again, I'm going to invite you to pause these videos and work ahead a step or two, just to try to test yourself as we go along. So the first step in every single one of these inheritance problems is always going to be setting your alleles. So feel free to pause the video and take a moment to set your alleles up, and then unpause it in about 3, 2, 1. All right, so remember, for X-linked traits, we have to set the alleles using the X as the base, and then we put a superscript of whatever letter makes sense for the trait. Um, for brown fur and orange fur, the big B, little b works great because they look different. I did notice on your first round of assignments, a lot of people were still using letters that look very similar, like F's and F's, or like things like that, or S's and S's, like C's and C's, things that look very similar. You see an uppercase B looks quite different than a lowercase b, so that's perfect. Similarly, then we have green eyes and yellow eyes. So we don't want to put a Y as the dominant here just because our other gene for like males is going to be a Y, so that would get confusing. So we'll go with capital E for eyes and lowercase e for green eyes. The whole point of setting these is to pick letters that look different and don't look like anything else. So then we're able to clearly organize information. So the way we got this is it says in cats, fur color and eye color are sex-linked. That's why we have the X. And brown fur is dominant over orange fur, so brown fur is the capital, the dominant allele, and orange fur is the recessive allele. And then yellow eyes are dominant over green eyes, so we got the dominant yellow allele and the recessive green allele. All right, so now our second step is to set our parent phenotypes. This one's a bit tricky if you've never done a multi-trait X-linked one before. So there's a little bit of a difference here than what you're used to in normal Mendelian genetics. That's why it's important to see the inheritance pattern. But if you'd like, pause the video and take a crack at it, and we'll pick back up in a few seconds here. 3, 2, 1. Okay, so here is the big twist on this type of problem. The man is easy because there's only one X chromosome, so whatever traits they have are all going to be on that one X chromosome, and then they're going to have the Y to be male. We're putting the trait for both fur and eye color on the same chromosome because everyone only has one set of X chromosomes, and if they're both X-linked traits, that means they're going to be on the same chromosome. So the gene still only has two genes, but this one gene of the genotype carries like the allele for two different traits because they're both X-linked. X-linked means that, or sex-linked means they're both going to be on the same X allele, or the X gene. You're going to have all these sex-linked alleles. They're just going to stack up there. And again, the man, it says an orange-furred, green-eyed, so he's recessive for orange fur and recessive for green eyes. And it's a male, so that means they're going to have a Y chromosome as part of their genotype, otherwise they wouldn't be a male. But then here's where it gets tricky. It says it's crossed with a brown-furred, yellow-eyed female cat, so dominant, that is heterozygous for both traits. This is where it's tricky. The female we know is heterozygous for both, so which is correct? I want you to take a second here and think about which one of these is heterozygous for both traits. Is this one heterozygous for brown fur and yellow eyes? For fur and eyes, so we got a big B here, little b, big E, little e. Then if we look over here, we got a big B and a little b, and a little e and a big E. So it looks like both cases are heterozygous. So how do we know which one to go with? Take a second and scratch your head here and think about how we could figure this out. It's kind of a it's kind of a non-answer. Okay, so this is an ambiguous case. You would have seen this word in your practice, but that means we have to use both. Based on the information that the question gave us, either one of these genotypes for the mother is equally likely. So we can't say based on her being heterozygous for both if she's this or that, because both of these genotypes are heterozygous for both traits. So we get to do both. So take a second and figure out the gametes for each parent here. Figure out the gametes, and keep in mind that we have to do two cases for the female. So I'll give you 5, 4, 3, 2, 1. All right, so the male is nice and easy, just one set of gametes. We got our X recessive, so our X little b little e. And then we got our Y chromosome. For the female, we got one case where all the dominant alleles are on one X and all the recessive are on the other, or the one where they're mixed up over here. And in either one of these cases, she's heterozygous for both traits. So we just have to make Punnett squares for each of these and keep saying or. See how I'm going to circle that? We just have to keep saying or, because we can't be sure which one it is. That's what we mean by ambiguous. There's two possibilities, because either one of these has the mother being heterozygous for both. So it's going to be one of these. We know that for sure. We just don't know which one. So we have to put both cases out there. Okay, so just to recap, we have our alleles here, and we have our gametes. We have, this is like case 1, and this is case 2. So we're going to do a little like 4A, 4B here. We're going to make two different Punnett squares, and then say it could be one or the other. And that's going to be how we're going to go for our answer. So I invite you to take a moment here to pause and lay out two Punnett squares, and go all the way to your ratios at the end, keeping in mind we're going to have two cases. So I'll give you 5, 4, 3, 2, 1 to pause here. And all right, so here's 4A. This is just going to be our case from this side we're going to make it. So the female still goes on top and the male still goes on the side. That hasn't changed. Then we have our female gametes and our male gametes, and we're just going to cross that through. So that's one potential outcome of this crossover here. But remember, we have the second case. So that's going to break down the exact same way, except we're going to use these different female gametes, which is going to affect the results of our cross. So here, see how we had X big E, or big B big E. Now we have X big B small e. And here we had X small b small e. Now we have X small b big E. Either way, they're heterozygous for both, but they clearly are different when it comes to making our Punnett square. So we'll just cross all these through. And now we have two cases, so we can just kind of fill this in. As Regina, I'll take that away for a second. Try to fill these in and describe what the phenotypes would look like on your own. I'm going to give you like 5 seconds here to pause it. And keep in mind the answer is going to have two parts once again. So 5, 4, 3, 2, 1. So based on 4A, we have a genotypic ratio of 1 out of 4, X big E, X big B big E, it's a tongue twister, then X little b little e. That's this one right here, because there's one of these genotypes out of 4 possibilities. Then the same is true for the rest of them. There's 1/4 all recessive, X homozygous recessive for everything. Then 1/4 is like the male that's homozygous dominant. It's actually not homozygous dominant because there's only one. It's just both dominant alleles, then the male with both recessive alleles. So our phenotypic ratio is 25% brown for yellow-eyed female, 25% orange for green-eyed female, that's the recessive, 25% brown for yellow-eyed male, and 25% orange for green-eyed male. And you'll see when we describe the second case, everything just kind of gets shuffled around. So we have our or with a nice circle coming back again. Then here, you see our genotypes are just different because instead of being like the big ones together, the dominant ones together, we're all swapped around. So we end up with a quarter X dominant B recessive E, X recessive B recessive E. You can read these out. These are just taken from here. But we end up with 25% brown for green eyes female. See how these are swapped? Here it was brown for yellow eyes. Now we're kind of shuffling them around. So it does change our phenotypes. So 25% brown for green eyes female, 25% orange for yellow eyes female, 25% brown for green eyes male, and 25% orange for yellow eyes male. So this would be your final answer. You'd have these two cases with a nice or in the middle, saying this is an ambiguous case, so we know the answer is going to be one of these, but based on the information it gave us, we can't be entirely sure which one. So when you see an X-linked one where there's multiple traits and the person's heterozygous for both, like the woman, that's always going to be an ambiguous case, so keep that in mind when you notice that in your questions or in your practice. This is a lot to take in, so feel free to rewatch this video again and look at the key posted, which will have an example of this as well. And email me with any questions at mrbsciencemb@gmail.com. Hope you all have a lovely day.